Good day, everyone. Vision Analytical has introduced two new particle shape instruments known as the Sentinel Pro Particle Insight. It has new features that are significant. A new light source has been added that allows better resolutions for small particles. Optics have been improved so we can see 1 micron diameter particles as well as 1 micron particle shapes. 32 shape modules to classify particles with the best selected parameters. Shape analysis and the 32 shape displays distributions are done in real time as images are captured, giving users instant results the moment analysis begins. The system can suspend particles in both aqueous as well as organic solvents. There's a new interface that uses Windows 10, of course, but it's a Windows 10 touchscreen, so you can run the Particle Insight and do reporting with the monitor or the mouse as you see fit. Statistical process control capability is included, and the ability to track shape changes over user-defined time intervals. So for example, you could actually look at the dissolution of ingredients into, say, a solvent over time. You can do 1 minute intervals automatically and then overlay those results to show how well the particle has gone into solution. Now the units, it's available as a standalone version, runs by itself, or a shape module that you connect to a laser instrument. And we currently have kits to fit up to the Malvern Massicizer 2000 and 3000. The subject of this video is the quantity of finds could be more important than particle size distribution. Particle size distributions put out by the laser have proven themselves to be repeatable and accurate when all the sample preparation protocols are well defined and are followed. You will get repeatable results. Samples that perform differently must have some other causing characteristic than particle size if they are functioning differently and you cannot see them in their laser results. Laser particle size distribution devices measure all particles as if they were spheres. It looks at the light scatter around the particle and calculates an equivalent circular area diameter sphere of the light of that light that represents. So the more your particles are not spherical, the more the laser is measuring your size distribution too coarse. As the particles become less spherical, they're being reported as too large. Sometimes laser results cannot give you enough information why a sample performs differently in your process, or why a sample result cannot be repeated accurately. You get different results even from the same sample using laser, which says that there's something different in the sample. This new version of Analytical Sentinel Pro can measure equivalent circular area diameters with 31 other shapes, even down to as low as 1 micron. Using the Sentinel Pro that connects to your Malvern laser can help solve sample preparation issues. You could be using an observation that's too high for the Malvern to get repeatable, but you can see what those are if you should capture images and have multiple particles in the images. That represents that the concentration is too high. The Vision Analytical Sentinel Pro Shape Module connected directly to your laser extends the laser's capability to consider size and shape on the same exact sample. Removes sample preparation as being an issue. Excessive finds are difficult to identify and, more importantly, quantify when using a laser instrument alone. This presentation displays one analysis method and reporting format for using the Particle Insight to measure the significance of finds. What you see in front of you is a volumetric distribution of a silicon carbide sample labeled F8. This is the volume distribution. It shows particles at 50 microns This is the percentage of volumetric particles that it represents, and these are the microns in volumes. So this says we do have a 50 micron particle. We have some here at 35. We've looked at 20,000 particles in this particular case. We're using the particle insight, but we're representing it as if it were a laser result. 11.4 microns is the mean, which is right here. And 10% of the particles are less than 7.8 microns, and 90% of the particles are less than 15 microns. And we only have a few samples that are above 30 microns. Just a few. This is sample F8. Another sample, which may be functioning differently, is known as silicon carbide F6 and its volume distribution. We have more samples above 30. We do not have any samples that are 50. This distribution appears to be a little wider. Again, we looked at around 20,000 particles. The mean is 16.4 microns. 10% of the samples is less than 10.6 microns, and 90% of the sample is less than 22.9 particles. So this distribution is somewhat wider, but it has more particles above 30 microns, but it doesn't reach 50, like sample 8. So our initial observations are sample F6 has a mean of 16.4 microns, and sample F8 11.4. So that says that F6 is roughly 44% larger than F8. The F6 distribution is tighter when you compare the D10 to the D90. 10.6 versus 22.9 versus 7.8 versus 15. This is 2 to 1, and this is not 2 to 1. So this distribution is tighter. F8 shows smaller D10 particles size classification, so it has smaller particles. F8 and F6 particles above 30 microns forces a result that makes the F6 look like bigger particles. Now, one is curious whether we'll be able to get repeat analysis for these three particles, 2 50 microns and 1 35 micron. We probably should do an additional analysis to see that these particles indeed show up on subsequent analysis. Sentinel Pro Particle Insight has special reporting capabilities. If particle size mean D10, D50, D90 explain the relative process behavior of two different samples, we just need to prove it to ourselves we can repeat these results from the same sample. We can use the laser or the particle insight and equivalent circular diameter and get repeatable results. But if we cannot then look at these results and rationalize why one sample is different from the other, we need to look deeper into selected particles for reasons these samples react differently. Particle insight allows us to select any equivalent circular diameter size range, see those particles, and report statistics across this selected range. The Vision Analytical Sentinel Pro can allow us to see images of each and every particle size and shape over any selected range. We can isolate and see each particle greater than 30 microns for each sample. So in the case of F8, we actually can bring up those three particles that represents 50 microns, two particles that are 50 microns, and one of them that is 35. In the case of F6, we can bring up actual images that there are 36 particles above 30 microns, and we can actually see what those particles look like. So sample F8 has the largest particles up at 50 microns. Vision Analytical Pro module connected to the laser extends the laser's capability to consider size and shape on the same exact sample. That removes sampling as a variable when you're comparing particle size to particle shape. Volumetric distributions focus us towards the larger particles away from the smaller particles. Let's see what the overlay graph is using a volume distribution. What you see is a sample F8 versus F6 Volumetric Overlay. F8 is blue and silicon carbide F6 is red. Visually, sample F6 has a larger quantity of particles above 30 microns, remember 36, and the F8 only has 135 and 250s. Sample F6 has many more particles with an equivalent circular diameter greater than 20 microns. So if we look at 20 microns, there are a lot more percentages of particles for F6 than there are for F8. Okay? Now remember, F6 was 44% larger than F8. That explains it because of these particles here. In both cases, the larger particles skew their distribution analysis towards the large side. F6 is skewed worse than F8. Perhaps viewing both samples as a number distribution could shed additional light on what is different. Even though F8 has so few particles above 30 microns, sample F6 large particles have a similar contribution to the volumetric size analysis. Notice one thing though, neither one of these samples show any significant percentage of particles below 5 microns. Only these. There are none for either sample. That's pretty important. Numbers distribution instead of volume distributions focus our attention away from volumes and shows all particles as if they're of equal standing. Looking at a number distribution instead of volumetric focuses on the number of particles in any particular size. In this case, we're going to be using equivalent circular area diameter without comparing perhaps better description of shapes because it looks like this number might be sufficient. The Particle Insight Sentinel Pro can look at particles similar to a particle counter. If you make sure that the concentration of the particles in the liquid, or in the case of the laser, the obscuration, is such that we capture an image that has just a single particle, then the Particle Insight becomes an equivalent to a particle counter, where the laser can never do that kind of task. But it really isn't, the Particle Insight isn't functioning as a particle counter because it's dynamic. We might be seeing the same small particle more than once, but we're seeing that in the case of the laser also. But if we only have one particle per image, we now can use the Particle Insight as a pseudo particle counter. Sample concentrations must be chosen to guarantee that all images contain only a single particle. The number distribution removes volumetric bias and treats all particles as equal partners. Remember, we're using equivalent circular area diameter again, but the Sentinel Pro can report 31 other shapes for consideration if necessary. So what does these numbers distribution look like? Number overlay, remember, blue is F8, red is F6. Number overlay shows distributions are more uniform and not biased towards volumetric size. Note that all the particles above 30 microns disappear. We do not see these two particles here because those two particles represent a very small percentage of the total number of particles we've captured. So all these particles above 30 microns disappear on the number display if they are very significant in the volumetric display. F6 shows a greater bias towards the quantity of particles above 20 microns. We see this bias here. That is why it's 44% larger, because of these particles here that are added. It appears the quantity of fines for sample F6, the red one, is different than sample F8. The blue line is pretty uniform, 0, but F6, the quantity gets larger as it gets smaller. Numeric display observations. The Sentinel Particle Insight can select any size range using equivalent circular area diameter 8 microns. Now if we select 8 microns, we know for sure that we're going to capture all particles that are 5 microns or less. So we set the limit at 8 microns, and then we actually do analysis down to 5 microns. We can use the software to generate new size classifications just over this new range, 1 to 5 microns. We look at D10, D50, D90 for 5 microns and below. Quantity of fines for sample F6 below 5 microns is significantly greater than F8. Remember from the graph. Okay. Perhaps look at all these images below 5 microns to confirm using equivalent circular diameter is the best comparative measure. What is happening below 5 microns? Number display below 5 microns. Setting up the particle insight to select just particles less than 8 microns. All the 5 micron particles are representative. So we set the 8 microns. We ignore these in our distribution, and we look at just particles that are less than 5 microns. It says that this is a viable range. We don't necessarily have to include these in our statistics. So again, blue is F8 and red is F6. Setting up the particle insight to select just particles less than 8 microns will allow us to focus on just these small particles. This graph now shows how many and the smaller sizes of fines represented in sample F6. The Sentinel particle insight allows us to recalculate statistics just for these small particles, removing the large volume bias in the statistics. We can now begin to quantify all particles below 5 microns and the differences of these samples. Number overlay display observations. We can see that sample F6 not only has more fines, but they are smaller and increase in number as they approach 1 microns. See how this gets up to 3%. 3% of all the sample F6 particles are within 1 to 1.5 microns. F6 has significantly more fines below 5 microns. Sample F8 has none or very, very few particles below 4 microns. How many? This is a numbers distribution below 5 microns. Looking at 1 to 5 microns, this is sample F8. The mean is 2.9 microns. 10% of all particles are less than 1.1. 90% of the particles are less than 5. F6, 256 images. Mean is 1.4. 10% of the particles are less than 1 micron. 90% of the particles are less than 1.9. So these particles are significantly smaller than these particles. That's why the mean is 2.9 for the F8 and 1.4 for F6. But notice we've had 25 particles measured below 5 microns for F8, but 256 particles below 5 microns for F6. Sample F6 has 10 times the number of fines below 5 microns. Most of sample F6 fines are significantly smaller than sample F8. Sample F6 volumetric means was, remember, 44% larger than sample 8, yet it contains much more fines. Resample F8 to see if you can repeat the measurement of any particles above 30 microns. Sample F8 could produce a tighter, more uniform particle size distribution with less fines. Sample F8 could be the superior product. How do these samples perform in your process? Are they different? How are they different? Perhaps we know why. Perhaps it's fines. Vision Analytical can run free sample evaluations for the standalone particle insight and shape module connected to the Malvern Massicizer. Prior to scheduling any demo, we would like to perform sample analysis, free sample evaluation analysis, present our findings with a WebEx, and discuss our recommendations for moving forward. We ask that this is a prerequisite before considering moving forward with any on-site demo. If you can get your customer to send us 2 to 3 samples that perform differently in your process, we would try to identify those differences in our lab. If you could have your customer retain half of these same samples, then Vision Analytical can produce the same results we have done with the sample evaluations during installation and training. Perhaps then there will be no need to have a demo if the evaluation samples prove of some viable features that are acceptable. Then the customer has less risk for you to decide that you need a demo to proceed. They could decide they don't need to delay for a demo to make a decision or schedule a demo. So the results being identical during the evaluation on the same samples with being part of our guarantee, I think this risk has been minimized. We would like to show you shaped pictures of your materials and the differences between those materials, and you might be surprised how irregular they are and how different they are. And it could be fines. Please visit us at www.particleshape.com. There is also a link to a page where you have sample evaluation forms that you can fill out, and please send samples in at your convenience. We will try to turn around the results with 1 week. Thank you for your time.